Okay, so welcome to part two, and now we're going to go over some Ethernet errors, and then we're going to finish up this slide deck by going over fiber and Wi-Fi, our other layer one transmission mediums. So Ethernet errors. So when we're talking Ethernet errors, we mean actual interference or something going wrong on the actual wire, right, of our Ethernet cable between the source and destination, or just anywhere, right, on our NIC. So input error is really just an all-encompassing term that describes any error that happens here, right, on the physical medium. So you can see here, we did a show command on our Cisco CLI, on our switch that says show interface. And we have a bunch of output here, but if we focus right here, we have whatever this crazy number is of input errors. And these input errors could include a lot of different things: runts, giants, CRC errors, jumbo frames, which we're going to talk about in the upcoming slides. So CRC, this is a cyclic redundancy check. This is a calculated a calculated value in the FCS, or the frame check sequencing field of an Ethernet frame. So in that Ethernet header, we have something called the FCS, which is going to generate a value that is going to be used from source to destination to ensure that we didn't have any fragmentation, right? So a CRC error occurs when a network device is going to receive that Ethernet frame with a different CRC calculation than the CRC value calculated by the original device. So these CRC errors can be caused by several different factors. So typically they are caused by a defective cable, a bad transceiver, or when I say bad, really the wrong SFP transceiver. And this is going to be for our fiber connections. Or by the switch port just having errors, or the upstream network device, okay? So that is a cyclic redundancy check. And then we have runts. So runts are going to be Ethernet packets that are less than 64 bytes, and this may be caused by excessive collisions. So if you see a lot of runts in your show interface command right here, you may be getting some sort of collisions or interference on that wire that is deleting a lot of the data in that frame. So from source to destination, you can't recreate that frame properly with all the data payload. Then we have jumbo frames. So jumbo frames are frames that are bigger than the standard Ethernet frame size. So this is getting into what we call MTU, which stands for maximum transmission unit. So the typical MTU size is going to be 1500 for the entire frame, right? So what a jumbo frame is really just a huge frame, right? Which could be an issue, right? If we're not configured for jumbo frames, what happens is we start fragmenting that frame, and data may arrive out of order and could affect our throughput, right? There is a way to configure to accept these jumbo frames on the actual wire or on the actual interface of that switch, but we won't cover that. We just need to know what a jumbo frame is. And then we have duplex. So duplex is how data is sent and received on that Ethernet connection, okay? So half duplex on an Ethernet connection means you can only send or receive at one time. Full duplex allows both nodes, the sender and receiver, source and destination, to send and receive at the same time. So if we have two devices here, right? Our sender or our source and our destination, and one is configured for half duplex and one is configured for full duplex, we're going to have what we call collisions. And this is a duplex error, a duplex issue, right? So typically, devices are now set to auto duplex. And when you plug these devices in, they're going to talk to each other and say, okay, we're both going to use full duplex. Because with our Ethernet standards and speeds nowadays, you want full duplex, right? So you can send and receive at the same time. So if we look at this command here, show interface status, we can also see what the actual interface is set to. And as you can see here, this duplex is set to auto. So if we have a situation where for some reason the NIC on this computer is setting itself to half and this switch's interface is set to full, statically set, right? We're going to have collisions there, or what we call a duplex mismatch. And that duplex mismatch can come across as a syslog message on your actual CLI if you have your syslog messages turned on. Okay, and then we just have collisions, right? So a collision is just an event that happens on an Ethernet network when two stations simultaneously talk on the wire. And this is, again, just an issue when you're dealing with half duplex or duplex mismatched links. So we have collisions. Okay, enough about Ethernet, right? I feel like we did a nice deep dive into layer 1 technologies. We went over copper media, and now let's jump into fiber. So just before we get into the actual slides and these bullet points, I just want to mention or talk about these deep sea fiber connections here. I still have family members that they can't fathom that there's fiber at the bottom of the ocean seafloor that's transmitting petabytes and terabytes of data between different continents. But yes, it's true. The fiber that they lay on the ocean is not going to be the same single mode fiber you see in the data centers. They're probably not this small. The individual strands may be, but you just like to go over that, right? That this is a recent map. I don't know how updated this is of all the fiber connections across the globe. Pretty cool. But now let's dive into just fiber overview. So optical fiber cable is going to allow us to transmit data over long distances and at a much higher bandwidth than any other networking media, to include wireless or copper. So fiber is going to use light, right? It's going to use optical media is what we call it. But it's really just light going through a glass core. So because of this, we are less likely to have attenuation. It does happen, right? The light can only go for a certain distance and keep up a bandwidth capacity, but we're immune to EMI or RFI because electromagnetic interference doesn't happen on light, right? So optical fiber is going to be typically used in our enterprise to connect maybe our comms closets or our data centers, right? So let's jump into a different type of fiber. So it's more overview. So optical fiber is typically flexible but extremely thin. It's just a transparent strand of very pure glass that sends light, right? So bits are encoded on fiber as light impulses instead of electric impulses. And then as we can see here, we have different types of fiber with different types of connectors. So we're not using RJ45 for fiber connections. We actually have a lot of different types of connections, as you can just see in these pictures here. And then yellow is typically going to be what we call single mode fiber. Single mode is going to be used for longer distances and long hauls, okay? This is going to be where you send just one stream of light going straight through that glass core. And then we have multi-mode fiber, typically represented in this orange cable, sometimes in this light blue. This is going to be for short distances, but has much higher bandwidth than our copper cable. And then multi-mode is going to be a light refracting across the glass core. That's why it can't go the biggest distance as single mode. But it's great for just our connections between data centers, maybe on our campus network. So here we go, just a little bit more in depth into the differences between multi-mode and single mode. As we can see here, this glass core in single mode, it's just one light going across, which is good for our long hauls, right? As you can see here, these long hauls could be 40 kilometers or more. Then we have multi-mode. As you can see here, we got different beams of light kind of being jumped or, being sent across this glass core and kind of refracting off, okay? And so it can propagate multiple light modes. This makes it more suitable, again, for those campus installs, and typically you're going to have 400 meters or less. And again, this orange and this light blue, I've never seen the light blue personally, but I know orange is always MM or multi-mode. And then this yellow is always SM, single mode. And the reason I'm representing it in this abbreviation is when you work with SFPs, these are the fiber modules that you can plug into your switches to give a fiber capability, they're going to be labeled. You got to be able to recognize SM. Okay, that equals single mode. So for this SFP, I got to use single mode, right? multi-mode. And then up here, we have the different types of connectors that you can use for fiber. As you can see, there's a lot of different ones. The important thing to note for the exam and for just in real world, right, is to make sure you have the correct transceiver when you're doing fiber connections across your enterprise. Okay, again, going over the different connection types. It's important that you just have the right connection type for the right transceiver on your switches and your routers. And then testing fiber. So this isn't something that we get into on the exam, but for real world, this is something you do need to know. Now, a lot of times, if you work with fiber, that's going to be your main job. But because we're net engineers and we may work in a data center, we may need to do some what I call like a level 10 task for simple troubleshooting of that fiber. And one way we can do that is by just sending a laser or light across the fiber and making sure that light is coming out both ends. So I've had to do this a lot when doing data center installs and troubleshooting across bases or across cities. Testing that light and making sure there's no obstructions here, making sure the glass didn't break somewhere or that the laser has a strong output. Now, this isn't 100% test, meaning just because you see light does not always equal that data is going to be passing, okay? So this is when you go actually call your E&I team and whoever works in your enterprise to actually deal with this physical layer. Okay, and then more testing of fiber. So you have something called the optical time domain reflectometer, and this can be used to actually test the fiber optic cable segments to make sure that you are getting data passed across that fiber. Okay, so now that we went over a quick overview of fiber, there's something I also want to mention for you, for everyone taking our paid course. So we're going to also have a sheet that you can download of all the important transceivers and the different standards for fiber speeds that are going to be very important for the exam. Okay, obviously not talking about what's on the exam, but I've had students say that it's important that we understand the different fiber connector standards and different speeds and what transceivers work for which types of modes, right? Single mode or multi-mode. So now moving on from fiber, let's quickly go over wireless. And I say quickly because we're going to have a whole section dedicated just to wireless technologies and principles. So we're going to just talk about the important terminology. So wireless media is going to carry electromagnetic signals across microwave frequencies, okay? So what do we mean by this? So in Wi-Fi, we're going to send microwave transmissions to represent our bits, and this is also a layer 1 technology. So RF, radio frequency, describes the wireless signals that connect your Wi-Fi enabled devices to your network. And again, frequencies are going to be measured in hertz. So when we're talking wireless speeds and different frequencies, we're going to be measuring them in different hertz. And hertz kind of work like bits. So a kilo is 1,000 hertz. Mega is like 1,000 kilohertz. So as you can see, is the jump here. Then into giga, mega into giga. And then we have SSID again going into our wireless terminology because this isn't a ham radio course, so we're talking stuff that is specific to Wi-Fi. So the SSID is a service set identifier, which is the unique name that identifies your wireless access point. And a key note that I didn't put in this slide is your SSID, according to Cisco, cannot be longer than 32 characters. Okay, so important note to jot down. And then we have the different Wi-Fi or wireless standards. So the IEEE 802.11 is the, again, or IEEE, the governing organization. 802.11 is going to set the different standards and speeds and frequencies for Wi-Fi. So as we can see here, 802.11 AC, a common one nowadays, has a maximum speed of 1,300 megabits per second. And then we have 802.11ad, which also bumps up to 7 gigabits per second. You may hear these as Wi-Fi 5 and Wi-Fi 6, which again is something we're going to go over later in this course. So for now, I just kind of want to get you familiar with the 802.11 standard and the different frequencies they're going to operate in, as you can see here, okay? And then let's go over wireless devices, which we kind of went over in our previous section of network fundamentals. But we have our access point, and this is going to be the device that sends and receives signal from our Wi-Fi enabled devices. And then on our computers and our endpoints, we're going to have wireless NIC adapters, which are also going to provide the wireless communication capability to our network host or our endpoints. Okay, so that's going to be everything for layer 1. I want to thank everyone for sticking through. I know it was long lectures. And when we jump into layer 2 in our next section, we're finally going to be more CLI focused. Once we get past this layer 1 and what I call layer 0, learning our network fundamentals, is the course starts to get more fun because we're going to get deeper into labs. So as we get into layer 2, we're going to dive deep into our fundamentals and then immediately hit the CLI. And it's going to be the same way for the rest of the course. So I want to thank you guys for viewing and stay tuned for our next videos.